Hello, I'm Christy Wilson. I'm a software engineer at Google, and I am excited to talk to you today about how to get a better signal out of your tests, and in particular, how to deal with flaky tests. The context in which I'm talking to you about this today is that I'm writing a book called Grokking Continuous Delivery. If you are interested, you can get an early access preview to it. I am today focusing on the fifth chapter of the book, which is all about dealing with noisy tests. So I want to try to demonstrate to you some examples of noisy tests and show you how you can handle them. And some of it is, I think, not what you would guess, which is why I think this could be an interesting topic. Which leads me into the first point that I wanted to make is that I think when people think about noisy tests, they often think about tests that are failing. If your test suite has some tests in it that fail, you might think of that as noise. And when a test fails, you're like, oh no, there's more noise. And so I wanted to kind of try to convince you that actually it's not quite the same thing. It's a little bit more subtle than that. When we talk about noisy tests or noise, we're usually talking about this kind of in the context of the idea of there being a signal and there being noise, where signal is some kind of information that we want, and noise is something that distracts us from that information. So what does that mean with tests? Again, we often think about the noise in tests being failing tests, but it actually turns out that both successful and failing tests can be noise, and they can both be signal. The idea is, are you getting any information from them? Tests exist. They exist to give you information. They also exist to help you kind of structure your code in a way that is higher quality, but we're just going to leave that to the side and just talk about the signal that you want to get out of your tests today. If you have tests and they pass, if they pass and they should pass, they're testing what they should test. If something was broken, they would fail, then that is a signal. However, there's also another version of a successful test where it actually could be noisy. If it passes, but it shouldn't pass, maybe it's not actually testing the error condition correctly that it's trying to test. There's something wrong with it. That's actually noise because the information is hidden from you. You're actually not getting information that you want from the test, which is that there's something wrong with the functionality that you want to address. With failures, it's a little bit more straightforward, but the real key is that failing tests become noisy when they're not giving you any new information. As long as you're getting new information out of the failure, then that is a signal, and that's what the tests are there to do. They're there to tell you when something goes wrong or that nothing is wrong. And so ideally, you want to focus on getting your tests into the signal range as much as possible, which means they're only passing when they should pass. And when they fail, you're getting some new information out of it. I think what happens over time is that a lot of our test suites tend to slowly fall into this bucket where there are failures in the test suite, but they're not giving us any new information. We already know there's something wrong. We don't know what that is, but it keeps failing. So how do we deal with noisy tests? Again, the idea is to go from noise to signal, so from this distraction to the actual information that we want. And this really applies to your entire test suite. You can look at it on the level of individual tests, but ideally you want your entire test suite to be giving you a solid signal consistently all of the time, which usually means getting it into a generally passing state as the norm. Otherwise, people kind of tend to slowly lose trust in it over time. The more that you have a test that's failing periodically in a test suite, people stop trusting the failures to actually mean something, they don't think the failures are signals anymore, and they start ignoring them. So what are your options if you have noisy tests? The best option is to try to figure out what's actually going wrong and fix it. It seems pretty obvious, but we'll look at a couple examples of this today. It's obvious, but it's the one that takes the most time. This is definitely the hardest option. It also means you have to really go and understand what's actually going wrong when you encounter a failure, which you may not have time for. You can also delete the test. This would be probably one of the rarer options. You would only do this if you feel that the test is actually not providing any value. It's just providing noise, and there's no reason to try to fix it because the same functionality is covered by something else, or it's testing something that you just don't think is worth trying to reproduce on a regular basis. The last two options are options that people reach for pretty often, but I would like to suggest to you that these are usually just stopgaps. They don't actually address the root cause of whatever the problem is that's happening with your test because they allow you to sidestep it. So in one case, you can sidestep it by disabling the test so it just doesn't run anymore. It's just not producing that noise, but it's still kind of floating around there somewhere. not not giving you any signal, and probably never to be returned to ever again. Or the last option is to retry the test. I think that's what a lot of people do, especially when they're faced with flaky tests, which we'll get into in a bit. So tests that sometimes fail and sometimes passes, they will just retry them until it passes, feeling that, as long as it passes eventually, that's the most important thing. This is an overview of what it actually means for tests to be noisy and what your options are in dealing with those. But let's get out of these slides for a few minutes and let's take a look at some actual tests and what it takes to fix them. So I've got a repo set up with some examples. I'm also trying to keep an eye on if anyone asks questions, but I keep closing the window over here. So please feel free to ask any questions you might have, spice things up a bit. Anyway, okay, so I've set up this repo. It has this beautiful library in it. It's all about ordering ice cream. It's extremely contrived, but it should help us demonstrate some of what I want to show you today. So I would like to show you. Okay, first let's just take a look at a test that passes and provides us with a signal, with the signal that we want. So over here in our editor, let's open up our tests, and the very first test that we're going to look at is test add multiple. So this is a test that passes, and it should pass because it's effectively testing what it's supposed to test. So when this test runs, it uses a function to conveniently get an instance of this orders class that has some orders added into it, and then it checks that the orders are what it expects. I mean, it's literally reaching into the class and looking at a variable, which is probably not what you want to do. But anyways, this passes, and it should. It's doing what it should. If we go over and look at what it's really testing, which is this add function, we can see that inside the orders class, whenever you add an order, the order total is incremented and the order is appended to it. I mean, if anything, we could update this to also check total orders. That would be an improvement on this test, but I conveniently wanted to have another test for that to show something else. But anyway, so this is your classic. This is a test that succeeds and it gives you a signal. So this is the upper left-hand corner of that chart. It's a successful test that gives you a signal. That's great. That's kind of boring too. This is what we want. However, as I mentioned before, it's actually possible for a successful test to be noisy. And there's a couple of ways that we're going to see that happen. But the first one that I want to show you is we have an example of it with this test get most recent. So the goal here is that we have this orders class. We have a function that's supposed to, or a method that's supposed to return us the most recent order. Because if you'll notice, orders are added with the time, the date. There's no time, it's just date. They're added by a date and then the thing that you're ordering, which in this case is the type of ice cream cone. And this function is intended to get you the most recently ordered ice cream cone. And what this is doing is it's asserting that the most recently ordered ice cream cone was Rainbow Sprinkle. If we go up and look at the orders, you can see that, yep, so on the 10th of September, we ordered Rainbow Sprinkle. That is the most recent order. So everything seems fine. But as it turns out, let me show you this passing first. It turns out there's actually a bug that this is covering up. So let's run our test. Oh, there's my flaky test, which we'll get to in a second. Why is it? It's so flaky that it's happening. There we go. Flaky test is flaking even more often than I wanted it to. So let's just ignore those two. Can I make it pass again? Okay. There's a flaky test hiding in there, which we'll look at in a minute. But so at the moment, actually, in fact, just for the purposes of this demonstration, I'm going to disable that flaky test because I don't want it to distract from this. Okay, so yep, okay, consistently passing. All right, so test get most recent is passing. Everything seems fine, but what if we change this around a little bit? What if we, for example, change the order that we're adding these orders in? This one is Rainbow Sprinkle is still the most recent order because it was on September 10th, but is it going to work? Let's see. So let's run the test. Suddenly, our test is failing. It's actually returning cherry glazed as the most recent order instead of rainbow sprinkle. And if we go and look at how this was implemented over in the screen file. Okay, let's take a look at get most recent order. So what get most recent order is actually doing is it's just getting the last order that was added. But what we really want is we want this logic to be aware of the dates of the orders and to look at those when deciding what the most recent one is. So actually this test before we made the change was a noisy passing test because it's actually giving us, it's hiding the signal that we need, which is that our logic here is actually not doing what we want it to, behind a passing test. So we look at it and we think that everything's fine, but it's not. So that's kind of a sort of a weird way to think about successes, but successful tests can also be noisy. So let's actually fix this test, and this will be fun because I don't write Python very often, so this is going to be take me a minute. So what we really want is for get most recent to actually be aware of the dates inside of the orders that are added. So every time an order is added, it's added with the date and the order, and these are stored in a default dict where the key is the date, and then there's a list of orders. So, and we don't have any times, so we could just assume maybe the last item in that list is the one that we want. But let's see, so now what we need to do is we need to sort the dictionary by key. So let's see if we can do that, or if we need to sort the keys in the dictionary. No, that's not what I want to do. Sorted, I think there's a sorted dict that we could use as well. I don't know if we could use sorted and default at the same time, but let's just go for the easy thing right now and try to find, let's see, dict insertion order. That's cool, but it's not what I want. Key for key in sorted items. I wonder if I could just, let's see, let's say self.orders items. Sorry, let's say sorted items. The last one should probably be checking for none in that case. But, oh, I'm putting that in completely the wrong spot because live coding is stressful. Okay, oh, I'm using totally the wrong casing here too. Okay, most recent key. So yeah, I mean, I guess all I have to do is do the sorted items thing instead of a list. There, will that do it? I don't know if that's enough. Let's see. No, but did I save it? Oh, unhashable type list. And line 20. Sorted. Maybe assuming I could do this on the fly while live streaming was a little bit ambitious, but I still want to do it. I had some other changes planned that were more complicated. Maybe I should skip over. Let's see. So sorted. Oh, not items. I need the keys. Keys. Yay! Okay, cool. All right. So now I think we fixed it. Let's see, we should always get rainbow sprinkle regardless of the order that these, oops, that's the expected orders, that's not what I want. Regardless of the order that these are added in, I add it first. See, yay, it's working. Okay, so let's just leave that in the middle there. All right, so we fixed our test. We fixed our noisy passing test. Let's add that change and that change. We're not going to add that change for now. Fix noisy success. All right, then over here in our repo, let's type origin tracking. Over here in our repo, Let's do, I'm just checking my messages because I'm trying to see if someone's going to tell me that you couldn't hear me or something, but no. Okay, so let's create a pull request, fixing our noisy successful test. And in this repo, we have some checks set up. Now this unit test check is including our flaky test. So it's always a toss-up. Will it pass? Will it not pass? Which is back to the point I was making about how flakes in your test suites degrade your confidence in them over time. Okay, it passed though, so we're fine. We're feeling good about our tests. Let's merge it. Okay, so we have had a look at a signal that is a test, a signal that is a passing test, and a passing test that gives us a signal, and a passing test that gives us noise. Okay, cool. So let's take a look now at some kind of more examples that we're more used to, which are tests that fail. So we have a couple of tests here which will fail. So here I was skipping this test. Let's look at this one first, because this is more what people think about when they think about tests failing. They often think, oh, I have to fix the test. They talk about fixing the test, and it's interesting because the signal that we want to get out of our tests is whether the code that the tests are testing is working or not. So it's interesting that our minds kind of automatically jump to, I have to fix the test, when in reality, it could really be the code underneath that needs to be fixed. And that is, in fact, the reason that we're running the test, because we're trying to determine, is there a bug that we need to do something about? But this is kind of the classic case. This test is going to fail because there's something wrong with the test. So, oh, actually, hold on, before I do that, let me grab the changes that I made. Oh yeah, that's okay. All right, I'm gonna undisable that test. We'll just have to know when it fails and adds all of its noise that that's intentional. Okay, chicken out main. Let's pull in the changes that merged. Okay, and we're gonna fix our failing tests. All right, so let's run the tests. We might get our flake, we might not. Flake, flake, flake. It's never happened this often, I swear. Every time. It's a 50% chance. Okay, that time it passed. Anyway, but let's look at some of these tests that I have disabled. Okay, we're going to re-enable test get total orders. And oh man, it failed. What a surprise. All right, so test get total orders is using our function that gets us a seeded orders class, and it's expecting that there will be no orders in it. But this is just a mistake. So if you look at get seeded orders, it instantiates an orders class, but it also adds 3 orders to it. So there's no reason to expect that the total orders here is 0. This could, so what we could do to fix this is, what we're probably trying to do was you're probably trying to have a couple of different test cases for get total orders. So what we really wanted was, we wanted an empty orders class that has no orders in it whatsoever. That was what this test was really going for, and there it passes. So this, when it was in this state, this is an example of a failing test that provides us with a signal, and the signal was, your test is broken. So we fixed it. If we were to leave it like this is when it becomes noisy, where, if you're working on something, hopefully you wouldn't be committing this back to main, but that would be the worst case. But maybe you're working on something else and you've got this test and it's sitting there, and every time you run it, it says that the assertion fails, but you already knew that from the last time you ran it. So that is where a failing test starts to become noise, because you're not getting any new information out of it. You're just getting the information that you already had. So let's fix it. Let's restore it to the state that it was probably trying to be in, which was testing an orders class, as an orders object instance that doesn't have any orders in it. And maybe we'll add another case for when it does have orders. So no orders, and we'll add another one of these. Call it some orders. And in this case, we will go back to using our same seeded orders class, and this one has 3, because we know we're seeded with 3 orders. Now we have one case for no orders and one case with 3 orders. Look, they both passed. That's great. So commit these. In this case, it actually was fixing the test because it was the test that was broken. Anyways, I'd actually put even more details in the commit message than that, but I don't want to make you watch me type that. So let's look at our other failing test. Now this one is a test that will also give us a signal, but that signal is the one that we want, which is that there's something wrong underneath. So let's re-enable test submit orders and see what happens when we run it. It fails. Is that the right test? Test submit orders. Yep. Okay, it fails. It's saying the 3 does not equal 0, line 54. So what is happening in here? Test submit orders. It's instantiating the same seeded orders object. It's creating a fake ice cream provider, connecting to the fake ice cream provider, and then it is calling a method inside the orders class, which will submit the orders to the provider. And then it's checking that the number of orders in the class is in the object is 0. So this seems like it could be reasonable. I mean, just reading this, not knowing anything about what this is supposed to do, it seems like maybe after you set up all these orders, after you submit them, perhaps the internal queue of orders is expected to be cleared out. It's expected to have 0, but as we can see in the test, it actually has 3, which are probably the 3 that we seeded. So this is a case, again, of a test that is failing, and it's giving us a signal. It's saying that what you wrote in the test as the expected behavior of the thing that you're testing is not doing what you expected it to do. And just like with the other case, every time a test fails, you have to determine whether it is the test itself that needs to change or if it's the code underneath that needs to change. It's not always fixing the test. It's often actually fixing the bug that the tests are revealing. So let's go and look at submit orders. And so the submit orders function here is going through the items and calling process order on the service, which in our case is our fake ice cream provider. But it's not doing anything else. So it seems reasonable to me that maybe what we actually wanted to do here was we wanted to get rid of all the orders because we've already submitted them all. I do not want to think that this is necessarily a good way to design this. I think if you're actually trying to separate out functionality well, you would maybe not be mixing these things together where you're like submitting and then you're mutating all in the same place. But anyways, let's just put that to the side. That's what this function in this class is doing. So once all the orders have been processed, we actually want to clear them. So let's run that test again. And we hit our flake. Okay, but we fixed the problem with this particular submit orders test. It is now passing because we fixed the actual underlying bug. So that's the other kind of way that failure can give you a signal. And that signal could be that there is a bug that you need to fix. And that's really, besides tests being a good instrument to help us write better code, this is really the reason that we have tests and the reason that we keep running them is for exactly this purpose. So this test failure, again, it wasn't noise. It was a signal that showed me that there was something that I needed to fix. If I left it the way it was, then it would become noise. But let's commit that fix too. Just caught a hug. No, a bug. A hug. Okay. And now I'm hoping that we're going to actually see. So we're going to talk about flaky tests in a second. I hope we're going to see that test flake happen here on one of our pull requests. And there's a difference between these two things. In one case, there was a test that we had to fix. There was a problem with the test. So in addition to enabling it, we had to actually fix the test itself. So all the changes were just in the test code. But then in the other case, the only change we made in the test code was to undo the skipping. But otherwise, we actually had to make a change in the business logic that the test was actually trying to exercise. So test failures are not noise. They're actually a very valuable signal. And what you really need to do and should do as much as you possibly can is try to get to the bottom of why that failure is actually happening. And you're not fixing the test. What you're doing is you're trying to understand what the signal is that test is giving you. All right. I say fixing the test all the time. I'm not trying to say you shouldn't say that, but on the other hand, sometimes these phrases that we use do make us kind of fall into falling into habits which aren't great. All right, so fixing our tests. Here's our pull request. And now, because we have an unreliable flaky test suite, let's see if we're going to have a failure or if it is going to pass. I don't like waiting. Come on, run the tests. Ah, I passed. Well, I really wanted to show you rerunning just to get. Well, you know what? Let's rerun it. Let's rerun it one more time anyway because we can rerun.